and we are live on YouTube. Before beginning, I have an announcement to make. Vincenzo De Risi has just announced us that due to some very sad news, one of his friends died. He just found out, so he didn't feel up to speaking tonight. Therefore, we will only have one speaker, David, who is going to give his talk in a moment, and then we'll have plenty of time for questions. But let me welcome everyone to this kind of last academic meeting of the year of the Princeton-Bucharest seminar, which is meeting 49. At the end, we will have an announcement regarding next week. I will let Dan make this announcement at the end of our meeting tonight. But until then, let me introduce our speaker tonight. David Rabouin is going to talk. Well, the session was initially called, let me say, Logic Diagrams and Geometry in Early Modern Thought. And our paper will be on the dream of a purely intellectual mathematics in Descartes. David, you have the floor.
Thank you very much. So I will start sharing my screen. Is it good?
Yes.
Okay. Good, I guess. Okay, so thank you very much. I'm really sorry not to be able to exchange with Vincenzo because we also talk about this session together. So anyway, that's life. So I was asked to talk about Descartes' mathematics and more specifically about the relationship between algebra and geometry in Descartes. This is something I already wrote about in a more technical context, especially in my paper on the relationship between algebra and Mathesis Universalis at the time of the regulae. And also more recently in a paper on the role of imagination and diagrams in La Geometry. So here is the paper. So if you are interested by these more technical papers, please just write to me. I mean, they are easily accessible, but except the last one. So just I will send it to you. So what I would like to do today is to approach the question in a less technical setting, in particular in the framework given by the Méditation métaphysique, when Descartes tackled the issue of the relationship between mathematics and imagination, and especially the famous passage on the Kiliago. So I have reproduced it here. So I will not read this text. Everybody knows it, I hope. And I will not read parallel texts that you all know about the wax or the various passages about mathematical truth in the Méditation métaphysique, which you all know by heart. My only target tonight will be a certain reading of these passages. And then we can go back to the text during the discussion if you want. According to this reading, Descartes is criticizing the role of imagination in mathematics. And by the same token, he is defending an alternative way of doing mathematics, a kind of purely intellectual mathematics. On this background, one then often assumes that this relates to what Descartes did when he reformed mathematics, that is to say, algebraizing geometry. He replaced the role of imagination by that of the intellect, the pure intellect. Or to wrap it up in a formula, which could serve as a thread for my talk, algebra is to geometry as the intellect is to imagination. So this is the view I want to criticize. I don't say right away who did this, but you will see it later. So before entering into the discussion of this analogy, let me give you some hints of how this reading is widespread. So the first part of the talk will be about showing to you various people who have interpreted this passage from the Méditation as saying what I just said. That is to say, Descartes is alluding to the algebraization of geometry, and what he has in mind is a kind of purely intellectual mathematics, which is algebraic geometry. Let us have a look at the commentary that Gary Hadfield proposes of this passage in his chapter in Amélie Rosti's collection. So here it is. I don't know if you can read it. So I will just read the end of it. So he is commenting this passage, this famous passage about the Kiliagone and the fact that we have this, with the mind's eye, we see the mathematical object. So this here is what he says. One attractive answer embarks from Descartes' considerable contribution to the development of mathematical thought. A distinctive feature of Descartes' mathematics after the rules is that it abandons the idea that all mathematical operations should be depictable in the imagination. In his geometry proper, Descartes developed the notion of a pure science of proportion, expressed in terms of algebraic equations and conceived in terms of proportions among light men. Perhaps when Descartes spoke of a non-imaginary understanding of the triangle, he had in mind the kind of understanding that is embodied in knowing the equation for expressing the relation among the sides of a triangle, deriving the area of a triangle, and so on. The pure conceiving of the intellect are in this manner asymmetric to an algebraic understanding of continuous quantity and its proportional relations. So Hadfield doesn't adhere to this position. And this is what he explained just after the passage. But just to show to you that this is, according to him, the most attractive answer. And I will show to you that, I mean, there are grounds for this, because in the literature, you have many people defending this view. And then he explains that this is not very convincing. But what kind of understanding is that? The temptation of the 20th century mind to consider this as a kind of purely formal or symbolic understanding, whatever that will be, clearly will not do. Descartes' scorned attempts to make words or symbols and formal rules for manipulating them primarily. These are merely arbitrary sensory reminders for the content manifest in thought itself. So even if we suppose the pure conceivings to be algebraic, the question naturally arises of what it is like to contemplate a triangle algebraically, without the aid of imagination or of sensory thoughts, which puts us back at asking what's like to have a pure conceiving of a triangle in the first place. So I agree with Hadfield that there is a big problem here, but as I will show, the people who are defending the first view have an answer to give him. So we need to go a little bit further than this first criticism. Okay. So before turning to, Hadfield will defend another view, which is based on the relationship and a parallel with Neoplatonism that I also favor and that I also defended, and especially with Proclus philosophy that I also defended in other papers. I will not talk about this tonight. I just want to criticize the attractive answer that he mentioned and that he criticized. So before turning to examples of such a reading, we could ask ourselves what other elements we can find inside of Descartes to support such a view. So basically, there are two elements. So one element that is recalled by Hadfield is la géométrie, and the fact that la géométrie is supposed to be purely algebraic and without recourse to imagination. So just to show to you that this is not a view from pure philosopher who has no idea of what's happening in history, I chose an historian of math who says exactly that. And we will see other examples later. So it's not a question of having a philosophical reading of la géométrie. So here is it's taken from a paper by Giorgio Israel, which is called The Analytical Method in Descartes Geometry. And here is what he says. In fact, in the regulae, differences are described by means of reference to illustrated extensions applying to imagination, and in a certain sense juxtaposed to quantity. In la géométrie, this juxtaposition disappears. Actually, it transforms itself in a hierarchical relationship. In fact, the role of imagination disappears, and the size of extension is solved by means of algebra. More precisely, the quantitative descriptions of differences by means of extensions is realized in a purely intellectual way. And the instrument of such a realization is the algebraic description. So here you recognize the first part of what Hadfield was saying. The attractive answer is based on a certain view on Descartes' la géométrie as being a geometry in which the role of imagination disappears, and in which algebra is a purely intellectual way of doing mathematics. So this is the first big evidence to support this attractive answer to the mystery of the passage of what is a purely intellectual way to handle a mathematical object. And the second evidence, which is often quoted, is from the Discours de la méthode, because you remember that at the beginning of the autobiographical passage, Descartes recalled that then, as to the analysis of the ancients and the algebra of the moderns, apart from the fact that they apply only to very abstract matters and seems to be of no use, the former is always so closely tied to the consideration of figures that it cannot exercise the understanding without greatly fatiguing the imagination. And in the case of the latter, one is so subjected to certain rules and to certain symbols that out of it there results a confused and obscure art that cumbers the mind rather than a science that cultivates. And the conclusion of this whole passage with the rule of the methods and then the passage in which he described what looks like what he did in the Regulae is the following one. It's very famous. By this means, I will be borrowing all that is best in geometrical analysis and algebra and correcting all the defects of the one by means of the other. And it's very tempting that since the defect of geometry is to fatigue the imagination and block the exercise of the understanding, that to consider that what Descartes is saying here is that by reforming geometry, he just got rid of the role of imagination in favor of the pure understanding. So it's the second evidence that will be often mentioned. So I will now give a sample of various authors who have defended such a view and who have also answered to Hadfield's challenge. So just to wrap it up very briefly, what they defend is this idea that the algebraic geometry is a science of pure conceptual relation, and the imagination can have a role, but it's purely subordinated and it's dispensable. And in brief, the role of symbols, although it is imaginative by nature, is transparent. It's a way to represent pure relation and pure concept. So that's basically the answer to Hadfield's objection that we need to have symbols which are imaginative. So among the authors of the 20th century who have defended such a view, one of the most prominent one is certainly Brunswick. So unfortunately, I don't have an English translation. I don't even know if there is one. Of this very famous paper, which is called Mathématiques et Métaphysiques chez Descartes. And I'm sorry, but I will read it in French, but I will paraphrase it in English. So what Brunswick is doing is having a polemic with Gilson's commentary of the Discours de la méthode. And what Brunswick is arguing is that, in fact, the rules of the methods parallel exactly the geometry, the Descartes geometry. And here you have an example in which he comments on the third rule, in which, as you know, Descartes says that you have to analyze things to simple and then monter peu à peu comme par degré jusqu'à la connaissance des plus composés. And he comments on the fact that this is exactly what Descartes is doing in the beginning of the third book of La Géométrie, when he constructs equations by composing degrees bit by bit. So here you have the passage. I will not read everything, but I will just read the part in red. But I have to move your head. How can I do this? Right. Yeah, okay. So here is what he's saying. Le secret du rationalisme moderne est tout entier dans ce début du troisième livre de la géométrie, étrangement ignoré ou méconnu par tant d'historiens ou de philosophes. C'est là, en effet, que se caractérise, par opposition à la déduction logique, où la pensée se dégrade inévitablement à mesure qu'elle se poursuit, un processus de pensée ascendante qui est un enrichissement continu de vérité. So this is interesting because what he's saying is that, as opposed to the classical logic, what Descartes is doing is replacing classical logic by another logic. And so this is related to the topic of today's session. And this logic is basically the logic of the building of equation in algebra. Nous pouvons donc conclure, this is the conclusion of this passage, Descartes, en 1637, a parfaitement débrouillé ce qui, à l'époque des régulés, paraît encore embrouillé dans sa pensée, tout au moins dans l'expression de sa pensée. Non seulement les deux règles touchant l'ordre pour la mise en équation et l'ordre pour la résolution d'équations sont définies chacune à part dans leur précision caractéristique, mais encore la manière dont la mathématique détermine son propre objet subit une transformation radicale. Les régulés proposaient l'établissement d'une mathématique universelle qui tournait autour de la notion d'espace telle qu'elle existait dans la géométrie commune. Elle prenait pour point de départ l'étendue à 3 dimensions et elle généralisait la notion de dimension en assimilant à une dimension spatiale tout ce qui est susceptible de mesure. Mais depuis les régulés, en réfléchissant sur les moyens techniques que sa méthode lui offrait pour la solution du problème de Pappus, en opposition avec les procédés mis en œuvre par ses contemporains, Descartes est conduit à franchir le pas d'une importance décisive pour la philosophie. Il brise décidément la correspondance entre les dimensions de l'espace et les deux équations. Il crée une géométrie qui est avant tout une algèbre. So you see here the basic move, that is to say that what Descartes is doing when passing from les régulés to la géométrie is precisely to having a kind of formalism, which is purely algebraic and which breeze, as he says, the correspondence between space and geometry. Space is not given anymore, space is produced by the algebraic formalism. Il crée une géométrie qui est avant tout une algèbre. And then what he says is that the structure of space or the structure of the lines is no longer given. It's not intrinsic to the geometry. It's produced by algebra. I'm paraphrasing what he said after. And as you can see, I have underlined the passage in red. He called this a properly intellectual way of doing. So we find here again this idea that he's getting rid of imagination by replacing it by a purely intellectual mathematics. And I read just the end because it's very famous. D'où la révolution d'un intérêt capital pour l'histoire de la pensée humaine dans la relation entre l'esprit et les choses. L'espace de la géométrie paraissait vers 1629 un support indispensable pour le réalisme de la mathématique universelle. L'espace de la géométrie analytique est en 1637 un simple auxiliaire pour l'idéalisme de la mathématique pure. So no space is just an auxiliary for a purely intellectual reasoning, which is supposed to be given by algebra. And here is another passage in which, so the beginning of the passage is the commentary by Gilson, and Gilson quote the passage from the discourse that I recalled before, and he called the whole passage in which Descartes explained that he first represented things by lines, to open them to imagination, and so Gilson commented by saying that this is something that we have to overcome to go to metaphysics. And Braunschweig says, no, this is not true. If I am right, so I'm paraphrasing the end, in fact, he already did that in la géométrie. Or, si nos remarques précédentes sont fondées, nous sommes autorisés à dire que cette élimination de l'imagination, Descartes l'a opérée non pas en métaphysicien seulement, which was Gilson's position, that is to say, later, mais déjà en mathématicien, ce qui aura pour effet de mettre dans son système mathématiques pures et métaphysique rationnelle sur le même plan de spiritualité. So you would find many other authors defending this view. One typical example, I will not read all of them, is Jules Villemin. So this is the conclusion of Mathématiques et Métaphysiques chez Descartes in 1960. La mathématique de Descartes est purement intellectuelle en son principe. Descartes' mathematics is purely intellectual in its principle. And it's the same idea. It's the same idea, that is to say that contrary to the ancient, the geometry of the ancient in which the figure or space was given first and foremost, here space is just derived from algebraic symbolism, and everything is captured by purely intellectual relations, which are given by ratios and proportions. Okay, I will not read. It's the same idea. So amongst the philosophers, you will find many people defending this view, but certainly one of the most famous one, or at least it's an article which is often quoted from what I saw, is this paper by Gok-Roger, the nature of abstract reasoning, philosophical aspect of Descartes' work in algebra, which is in the Cambridge Companion to Descartes. And in fact, I will not read it, but he says exactly the same thing. That is to say, but maybe in a more in a clearest way. That is to say that algebra, and in fact, this is where I took my my picture. Algebra is to geometry as intellect is to imagination, and this is a commentary, if you look at it, to the passage on the Kiliagon that I already mentioned, which is my starting point. And here is another example, just to give you various examples. So this is a passage which is taken from Daniel Macbeth's Realizing Reason. The science of mathematics as Descartes understands it takes it as its subject matter, not object, but instead the relation and proportions that can obtain among objects, where this relation and proportion are exhibited in the symbolic language of arithmetic and algebra. Nevertheless, Descartes holds in the Galilei, the intellect should always be aided by the imagination. Although expressible in the formula language of mathematics, mathematical entities must also be capable of graphic expression. Around 1628, Descartes discovered, so he thought, that imagination is not needed in mathematics, that the pure intellect is an autonomous faculty of knowing. Certainly, we can imagine that it's from image of some mathematical entities. In Meditation 6, Descartes gives as examples a triangle and a pentagon. But in other cases, say that of a Kiliagon, we cannot. And yet, in every case, we can have mathematical understanding and knowledge as expressed in and mediated by the symbolic language of arithmetic and algebra. So you see, it's always the same idea. That is to say that what Descartes is referring to by opposing the Kiliagon and the triangle and the pentagon is that there is a kind of grasp that I can have a mathematical entity which is given by the pure intellect. And this grasp is given by algebra or by algebraic formalism. And the answer to Hatfield's objection, which is to say, no, but this is not true because symbols are a way to imagine things, is to say, yes, this is true, but in that case, imagination is subordinated to the pure intellect because it's purely transparent. It's just a way to express pure relations that are in my thought. Okay, so this is the reading that I want to criticize. And I think that its reading is like deeply misguided and wrong-headed. And for a first and very simple and straightforward reason, and this first and straightforward reason is that Descartes is not speaking in the meditation of a new mathematics at all. There is no question of reforming the existing mathematics by excluding imagination. His example show that what he has in mind has nothing to do with algebra and concerns mathematics in general. In fact, when one reads carefully the authors I have been mentioning in the first part, one realizes that they have to postulate that Descartes is alluding to his mathematical practice because he doesn't talk about it. That's the first problem. Notice, however, the following facts. First, there is no place in the meditation in which Descartes is talking about algebra, not one. He mentions at several occasions mathematical objects and mathematical truth, But its examples are either purely geometrical, like the triangle, or the inscription of a square in a circle, as opposed to that of a rhombus, or purely arithmetical, like 2 + 3 = 4. At first glance, and I see no reason to contest this reading, what Descartes is saying is that any mathematical truth, be it in Euclid, in Diophantus, or wherever you want to pick it, is purely intellectual. This has simply nothing to do with the algebraization. The second fact, on which I will come back in more detail later, is that there is not one place in his entire work in which Descartes will give what is supposed to be behind his claim in the Meditation. That is to say, an equation for the triangle or the pentagon. In fact, it is not clear what an equation for the triangle will be in Descartes' mathematics. So I just here cut and paste, one of these forum of university students, and the student is saying, but by the way, what is the equation for a triangle? It's not, think about it, and I will come back to this later. The second reason the reading I criticized seems wrong-headed is that Descartes is not opposing, in our passage, a mathematics based on the pure intellect to a mathematics based on imagination. He is opposing two usage of imagination in mathematics in order to make clear the epistemological difference between two faculties of the mind. And you can see this because the example of the kiliagon is contrasted with that of the pentagon or with the triangle. And in that case, what he says is that if the figure in question is a pentagon, I surely can understand its figure, just as was the case with the kiliagon without the help of my imagination. But I can also imagine a pentagon by turning the mind's eyes both to its 5 sides and at the same time to the area bounded by those sides. So it's not a question of eliminating imagination. It's a question of contrasting two usage of imagination. And we need this if you want to give an account of the many passages in which Descartes relates mathematics to imagination, even after the regulae. So here are some examples. In a letter to Elizabeth, 28th of June, 1643, I observed one great difference between these three kinds of notions. The soul is conceived only by the pure intellect. Body, that is to say extension, shapes, and motion, can likewise be known by the intellect alone, but much better, just hear this, but much better by the intellect aided by the imagination. And finally, what belongs to the union of the soul and the body is known only obscurely by the intellect alone, or even by the intellect aided by the imagination, but it is known very clearly by the senses. And later in the same letter, he says that the study of mathematics exercise mainly the imagination in the consideration of shapes and motion, accustom us to form very distinct notion of body. So I cannot see how you can give an account of this passage if you think that what he has in mind is in the passage from the Meditation is the elimination of imagination. It makes no sense that I can see much better by the intellect aided by the imagination, or I can form distinct notion of body by the use of mathematics, which exercise mainly the imagination. And he said the same thing to Mersenne in 1639, la partie de l'esprit qui aide le plus aux mathématiques, à savoir l'imagination, nuit plus qu'elle ne sert pour les spéculations métaphysiques. So that's the second line of criticism I want to address to this reading, that is to say that Descartes is not opposing two types of mathematics at all. He's contrasting two use of imagination. And in both, and we need, and there is one of this usage which is innocuous, which is the kind of usage that we have with the pentagon. So this, of course, is very important if we want to give an account of the passage from the Discours on which Gilson based his interpretation, which Brunswick wants to criticize. And I will read it. It's a passage which is between the criticism of the geometry of the ancients and the end in which he says that he corrected. geometry by algebra. Next, I observed that in order to know this proportion, I will need sometimes to consider them separately and sometimes merely to keep them in mind or understand any together. And I thought that in order the better to consider them separately, I should suppose them to hold between lines because I did not find anything simpler nor anything that I could represent more distinctly to my imagination and senses. So I think it's very clear that here mathematics is based on a distinct use of imagination. But in order to keep them in mind or understand several together, and here I put the French because understand is ambiguous in English, I thought it necessary to designate them by the previous possible symbols. In this way, I will take over all that is best in geometrical analysis and in algebra, using the one to correct all the defects of the other. So there is no question, as Brunswick claimed, to get rid of imagination here. There is, it's a question of expressing the role of imagination in geometry by algebra. Okay. So this leads us to the last reason to criticize the reading I mentioned, which is the study of La Geometry. So notice first that the beginning of La Geometry is in perfect accordance with what Descartes says in the Discours and in the Regulae, in the sense that it relies on basic diagrammatic descriptions of the elementary operation. So here is the very beginning of La Geometry. So you have diagrammatic representation for each operation. Okay. But this is not enough, since the supporter of the view I am criticizing objects that in that case, the diagram is dispensable. And in fact, it is true. You can get rid of the diagram. Descartes uses it, he presents it, but you can get rid of it. And this is what many of the Descartes readers, even at the time, did. So it is important to notice also that Descartes relies on diagrams in more complicated case, and that he has a diagrammatic practice. And this is what I want to show to finish, to conclude this talk. So first, there are many diagrams in Descartes' geometry. Here you have them all, okay? And not all of them are simple. So the first one are simple, but then it's getting more complicated if you look at them. And in that case, when they are complicated, it becomes less evident to say that they are dispensable because there are some information that are contained in the diagram and that you cannot dispense from them. But it is very important to see the way that Descartes is handling the object he is working with. So here is a passage from Sébastien Marron, PhD, in which he explained what would be the modern solution to Pappus' problem. The modern solution to Pappus' problem begins by setting up the equation of a line. You just write the equation of a straight line, then you write, so in this case, this is the Pappus problem with 4 lines. Then you just write the data of Pappus' problem, and you just derive immediately the type of solution and the type of locus that would be solution of this. And Sébastien is presenting this solution because this is not the way that Descartes is working. Descartes works with the diagram. And this is a very important comment that you have to keep in mind. Descartes never writes the equation of a straight line in La Geometry. Never. Not only that, he never writes the equation of a circle. Never. Okay. He doesn't introduce this type of object by equation. The way he works is with diagram. So here is what Descartes is doing. So you saw the modern solution in when you introduce you introduce right away the equation of a straight line. What Descartes is doing, so you have 4 lines which are given in a position. You just put them in a given position, which is quite arbitrary, and then you choose 2 of them. In fact, I can read the passage since we have a little bit more time than I thought. First, I suppose the thing done, and since so many lines are confusing, I may simplify matters by considering one of the given lines and one of those to be drawn, as for example, AB and BC. You see them in the diagram as the principal lines, to which I shall try to refer all the others. So it's a first step which is very important when you do Cartesian geometry. You don't have a frame of reference which is given in advance. You don't have space coordinatized. You choose given lines as your frame of reference intrinsic to the problem. Thus, in the figure, call the detachment of the light AB between A and B X and call BC Y. So you see here the two axes of reference. Produce all the other given lines to meet these two. Also produce if necessary, provided no one is parallel to either of the principal lines. Thus, in the figure, the given lines cuts AB in the points AEG and cut BC in the point RST. So I hope you look at the diagram, or I think it's not intelligible. So what Descartes is doing here is purely typical diagrammatic practice. He's producing the line and obtaining some new points that he will mark. Now, since all the angles of the triangle ARB are known, they are known because they are given in position in the data of the problem. The ratio between the sides AB and BR is known. If we let AB to BR be Z to B, then since AB equals X, we have RB equal BX on Z, and so forth and so on. So what is he doing? He is not setting the equation of straight line. He's looking for triangle, and each time he has a triangle, he will use the fact that the similitude of triangles will give them ratios between the sides, and bit by bit, he will build the equations that are needed in the problem by this diagrammatic practice. Okay. Second example. This is an example taken from the methods of normal. So in that case, you give yourself an arbitrary curve, and you want to produce the normal to the curve. And for that, what you need is the circle that will be tangent to the curve. So the normal will be the radius of the tangent circle. And what Descartes is doing is that he first supposes that the circle is intersecting the curve, and then he will say that in the tangent case, the two roots, the two intersection points, will identify. Now, let's have a look at how he does that. Really, I mean, the way he does that. So what we will do is to set an equation for the circle and for the curve. The equation of the curve is supposed to be given. But this is the way that Descartes proceeds. Or in fact, I will not read it completely this way, but just I underline the important point. He doesn't just use the equation of the circle. He never used the equation of the circle. What he used is Pythagorean's theorem, which is given by the fact that the triangle PMC is a right angle triangle. I have underlined this. And this is the basic relation that you need and that we take as being a way to characterize a circle. But he will never present this as an equation of the circle. Okay. And in fact, this is very important because Descartes explained this practice to the Queen Elizabeth. And you will see that it's very clear that Descartes has a diagrammatic practice, and it's completely wrong-headed that to say that the way that he practiced geometry is by using pure algebra, and you don't need the diagrammatic practice anymore. It's completely false. And in fact, Descartes said it. So I will read this passage and I will finish with this. In considering a problem in geometry, I always make it so that the lines which I use to find the solution to the problems are parallel or intersect at right angles as much as is possible. And I do not consider any other theorems, but that the sides of similar triangles have a similar proportion between them. We saw this in the first case. And that in right triangles, the square of the base is equal to the sum of the squares of the sides. We saw this in the second example. And he continues, and he says, I do not fear supposing more unknown quantities to reduce the problem to such terms, so that it depends only on these two theorems. So you have first the diagrammatic practice, and even if it produces too much unknowns and too complicated algebraic equation, we don't care. We don't care. This is what Descartes is doing and what he's saying here. On the contrary, I prefer to suppose more of them than fewer, that is to say, more unknowns. For by this means, I see more clearly all that I do, and in solving for them, I do better at finding the shortest paths and avoid superfluous multiplication. So I will stop here. I think I'm at the end of my time, yes, too much. And just, I think that my conclusion is very simple, very clear. I think that this reading of what Descartes is saying in meditation is completely wrong-headed. Doesn't correspond to anything. Doesn't correspond to what he says in the meditation. Doesn't correspond to what he says in the discourse. Doesn't correspond to what he says about mathematics in meditation, and doesn't correspond to what he does in la geometry. Thank you very much.
Thank you, David. Thank you for this wonderful talk. We have plenty of time for questions. Please do either raise your hand or signal in the chat that you have a question. Dan.
Thank you very, very much, David. And I think it's quite clear what you don't believe. Maybe you could say something a little bit more. Is there any about what it is that you might believe positively? Is there, and how is it that you read then the relationship between the geometry and the algebra? Is there any general statement that you could give to replace the mistaken view that you've so convincingly argued against?
Okay, so I thought you wanted me to give a positive reading of what is the relationship between imagination and pure intellect, which is, I think this is the difficult part. This is what I feel.
That is a difficult part, but I'm just wondering.
Yeah.
Okay, well, that too. That too.
Yeah, but the relationship between algebra and geometry, I think it's not so complicated or controversial among scholars today. I see that Marco Ponza is in the audience. But I think that the kind of view that was defended by Engboss is right. That is to say that in Descartes, algebra, although it has a very, very important role, and it completely changed the nature of the kind of diagrammatic inferences that we are allowed to do and are interested in, it's completely different than what happens in Euclid, for example, and Marco has written about this. It's a kind of completely different extension. It changed the type of object, because we can have, for example, curves of any degrees or object like this, okay? But still, when you look at the practice of Descartes, it's very clear that algebra is a tool for doing geometry. And that's, it's certainly not a way to replace geometry and diagrammatic practice, okay? And I think he's explicit about this. So I can say it positively, but I don't think it's very controversial among scholars. Some scholars, like it was the case of Giusti, it's the case of Israel, what they want to emphasize is the fact that in some cases, like in the method of normals, I need to give to myself the curve by an equation. That is true. That is true. But you cannot just isolate that part from the whole practice of what is in la geometry. Okay? And some readers from Descartes will do this, and that will go in very interesting direction, in which at some point in the history, you don't need the diagram anymore. But this is not what Descartes is doing. Okay, so that's the positive part. Algebra is a tool for doing geometry, and it's subordinated. It's the contrary to what Israel is saying. Algebra is subordinated to geometry and not the contrary. I will not give the positive answer to what is the relationship between imagination and pure intellect, because I think it's a really difficult question. It's a really difficult question. And so I have hinted at some of a possible answer in one of my paper, the one for Mattia Mantovani and on imagination. I think Hadfield is in the good direction by pointing to Proclus, but that means that you have integrate a kind of internal relationship between the faculties of the mind, okay, which is something which is complicated. So I don't want to enter into this because that was not the point. I mean, if we can base this problem as Hatfield is doing, I think we already did a great job because we're getting rid of the so-called attractive answer, which I think is really bad direction.
Can I just pursue for just a moment? Algebra is a way of doing geometry or helping to do geometry.
Helping them.
Say the opposite as well, that geometry can contribute to the solution of problems in algebra. Insofar as I remember, and I haven't worked on the geometry for many years, but my recollection is there are at least a couple of places where he's using geometrical constructions to actually solve algebraic problems as well.
Yeah, absolutely. You're absolutely right. This is the whole point of Engel's book. That is to say that the construction of equation is the core of Descartes geometry. So in that sense, it goes both ways. Yes.
Okay, well, thank you.
Right. Next question, Hanoch Benjamin.
Thanks. Actually, I wanted to make Dan's last point. That I was in complete agreement with you, David. I remember when I started reading Descartes, how it did not fit what we were taught about his geometry and algebra, but he certainly uses geometry to solve algebraic equations already in the 1620s. So certainly algebra doesn't have any priority in this respect over mathematics. But this is just repeating Dan's last point.
Yeah, and that's precisely the point. Algebra has no priority at all. It's instrumental, and then I can use also the reason why the construction of equation by intersection of curve is so important is precisely because geometry is the core. That is to say, to have a value, a numerical value, has no interest at all. What you need is to have a point. You have to have or a locus or something which is geometrical in nature. And in fact, when you look at the way Descartes talks about algebra, so he doesn't talk about algebra a lot. I did this research. I mean, the word algebra is not used a lot by Descartes. And when he wants to talk about like pure algebra, what he has in mind is the structure of equation as it is described in the third book of La Géométrie. He's not talking about the way that I can use equation for doing geometry. It's like really the structure of equation. And in that sense, this part is important because it can show you the number of roots and stuff like that and the type of the roots. But at the end of the day, what is the goal of all of this is the construction of certain locus, certain geometric.
Can you continue just a little?
Yeah.
So you agree, and I think this was part of Dan's point, that algebra is not only a tool, equations are not only a tool, but sometimes a target, because you can solve them by means of the curves, the parabola and but certainly they do not replace geometry.
No, absolutely.
Next question, Marco Panza.
Yes, thank you, David, for mentioning me. I essentially almost totally agree with you. I have only two critical remarks. The first one is very, very marginal. I think that you misunderstand Giorgio Israel's position in the paper. I know well this paper because I edited it. And Giorgio was just trying, I don't know, possibly it was not clear in the paper, but I'm sure to have discussed with him a lot of times that his purpose was to make clear the role of geometry, of synthetic geometry, so the geometry of imagination, so to say, in the geometry. Okay, but this is very marginal. Second point, that is not really a disagreement. I think but you said in a certain sense, answering the question of Dan, I think that the evidence that you gave for your thesis are all very good, but I think that there is one that is even stronger, and you did not mention explicitly, that is the very criterion of demarcation that Descartes presents. If the criterion of demarcation that Descartes presents between geometrical and mechanical curves as the one that he presents in the geometry, that is the one concerning the continuous and non-interrupted motion, and not the one that has been invented by many historians, that is a curve is a geometrical if and only if can be expressed by an equation. If the second condition is a consequence of the first, and the first is the real criterion, then there is no way to expel imagination for the foundation of geometry in Descartes, because there is no way to understand this criterion without the use of imagination. These are the remarks. Then a remark on the question, Dan question. Of course, the question is too difficult to have a short answer. But I think a tentative answer that I'm ready to deny tomorrow if you give me good argument, but possibly a tentative answer is that Descartes used understanding as a tool to describe what he sees by imagination. So the understanding, and in this case, the role that understanding has for the algebra formalism, he used as a way to describe what imagination make it clear to us, that is some geometrical situation. Then to say it is not to say that algebra has a marginal role in the geometry. The role is enormous, and it's so enormous that it may completely mathematical change is nature after Descartes. But what I think that is important, and I agree with David is that without a synthetical approach to geometry, the algebraic formalism, the algebraic revolution of Descartes would not have been possible. So the algebraic revolution, if I can say it, is essential, but it requires an essential role of imagination in geometry.
Yes, so I will take the remark. So about Israel, I think there are two claims which are different. One is about the relationship between geometry and algebra, which in fact was not the core of my talk. The core of my talk was the relationship between pure intellect and imagination. And so Israel says contradictory things.
Okay.
He says what you said. Geometry is the core of Descartes' geometry, for sure. But he also says, I quoted the passage, that this geometry is geometry of the pure intellect without imagination. And why? Because it was algebraized. And I think that this analogy is misguided. That was my point.
I would like to reread the context of this sentence. It surprised me a little bit, but I read this paper 30 years ago. But possibly you're right, but possibly the context is another. In any case,
I will share it again later.
Okay.
I can assure you that
the very problem is that poor George is dead, so he's not here to defend his point of view. So I tried to defend him because he was a very good friend.
You can. About construction, I fully agree. I didn't talk about this because this was not the core of my talk, but of course the question of the construction of curve, the very characterization of geometrical curve is another argument, very important one for this role that they are not given by equation. But I wanted to emphasize the fact that lines, triangles, and circles are not given by equation because I think that this fact is less well known. And in fact, it's important because when you read these authors, this is something that they emphasize. They say what Descartes has in mind in the passage where he contrasts the kidiagon and the pentagon of the triangle is that for the triangle, I can give an equation. And I think that not only is it false, but Descartes will never do it. If you want to give an equation for a triangle, you need at least to give the equation of 3 straight lines. This will be the most natural way to do it. or use other kind of minimal function or stuff like that, which is even crazier. So I wanted to emphasize this point, but I fully agree, of course, on the question, and you know that. And then about the question of understanding help us to grasp what imagination presents us, it's a little bit more complicated. It's a little bit more complicated because we need a role of presentation of the relation by imagination. And this role of presentation, which you have also in Proclus, is something which is not easy to explain. But what is interesting is that you will find in the Neoplatonism the same paradoxical kind of way to see things, that is to say, mathematical objects are pure concepts, but still we need imagination to present them. And so I think it's this is where the complexity here, or where the difficulty relies.
But very, very quickly, David, do you think that Descartes remain the idea that imagination is the solution to the problem of pluralization?
The problem of?
Pluralization, the fact that the concept is one, but the objects are many under the same concept. So we need a tool for pluralization. That was the idea of Proclus. So you don't think that is remaining Descartes?
No, I don't think this is the issue. The issue is more of showing the ratio and proportion. A way to presenting the ratio of proportion in imagination.
Thank you.
We have two questions by people. We have two people who have raised hands. We have two follow-ups or questions in the chat. It's not entirely clear to me which is related to what. There is a follow-up to Dan's point by David Miller in the chat. Maybe that would be fitting here. So David, would you like to read it loudly?
Alors, but you know
no, I mean, I know I was.
You mean the other David? Okay, yeah, that will be.
Yeah. To intervene with the voice.
Yeah, that will be better.
Can you hear me?
Yes, we can.
Oh, excellent. I wasn't sure if I could connect. So the question was, I understand that the relationship is difficult to properly express, but it seems like there's a reason to think that it has to be one or the other. This is the relationship between the intellect and the imagination. And the question is, well, it seems to be which of the two is Descartes ultimately appealing to? Because where's the source of the certainty of mathematical or geometrical knowledge, right? Is it in the objects that are represented in the imagination, or is it in logic, something like logical necessity that's stemming from the power of the intellect? So, so I was just wanted to try to pin you down a little bit harder on one side, or one or the other.
So,
sorry.
So this is precisely where things get confused when we mix or when we confuse algebra and pure intellect, because your questions mix the two questions. One question is the priority of algebra over geometry or whatever, the way that we think the relationship between the two. And the second question is the relationship between pure intellect and imagination. If we distinguish these two questions, we have the answer to your question. That is to say, what Descartes is saying, that the source of certainty is pure intellect, period. But what I claim is that it has simply nothing to do with the relationship between algebra and geometry. Nothing to do with that. There is no link, not in Descartes' text, not in Descartes' geometry. It's a confusion, okay? So the fact that we say, for example, that we claim that the geometry is the core of his practice doesn't tell us nothing about the privilege of imagination at all. It just says that there is a role of imagination, a diagrammatic basis everywhere, in algebra, in geometry, and so forth and so on. There are two separate issues. Do I answer your question? So the source of certainty is pure intellect.
Yeah, that answers the question, that the source of certainty is the intellect for Descartes.
And has to be the pure intellect.
Fair enough. Thank you.
Des Hogan.
Thank you very much. This is also a follow-up on Dan's question, but now it's also a follow-up on David Miller's question, because that your answer to him leaves me kind of perplexed. So I guess that, you know, in the debate about the role of diagrams in mathematical reasoning, there are minimal views, like say Leibniz's view, according to which it might have a heuristic value, but it's not central to the demonstration. And there are kind of maximalist views like the Kantian view, according to which it is essential to the demonstration. So Leibniz has this argument that the diagram is important. He even says that, you know, the senses are necessary to have definite ideas of things like lines and so on and so forth. But it's not essential to the demonstration, and it couldn't be, because the demonstration leads to certainty and universality, and you could never get this from an individual object, right? So, and a diagram is always going to be one particular individual object. So if it's the case that the imagination has an essential role here for Descartes, the question then is, what is that role going to be exactly? So if the imagination is presented with something like a singular diagram, a triangle, or what have you, then how could it be essential to a demonstration which is supposed to lead to a universal truth about all triangles, right? This is the Leibnizian challenge. And Kant has an answer, or some people think it's not an answer at all. It's just a way of, like, you know, moving the problem by introducing the notion of a schema, which somehow combines the universality of a concept with something like the individuality of the particular diagram, the pure intuition. So I don't understand, on your view, what is the role? So if you're not eliminating imagination, but you're expressing the role of imagination in algebra, what is that role? And is that role essential to grounding the universality of the demonstration?
Okay, so in fact, your question is about my other talk, the one that I gave for Mattia Mantovani about the role of imagination in La Geometry, which is a very small part of my talk today. My talk today was about the fact that this is not the proper way to read the meditation, okay? And so I did not develop all of these points. I mean, I can, but it's really another issue. And it's a complicated issue. I mean, I really did not tackle it fully, and it's normal that you have questions about this, but that was not the core of my talk. My talk was not about the fact that there is I just wanted to show that people claiming that Descartes eliminates diagrammatic practice in La Geometry and just use algebra is simply false, period. Okay, it's false. Then how to analyze the role of diagrammatic practice and inferences is a complex issue. But I will just give you a very short and small answer. So between Leibniz and Kant, you have many options and possible positions to analyze the role of diagrams in reasoning. And you have many people in philosophy of math who have worked on this issue, and especially on Euclid. And they realize that, in fact, you can have like middle ground in which what you do in Euclidean geometry is that you have a text in which you have some kind of reasoning with the text and the diagram, and you have some information that you have to take from the diagram. Does it tell you that the diagram is essential to the proof? Certainly not. Why? We know that Euclidean geometry circulated without the diagrams. We know that. We know that for sure. But what it tells you is that you need to have two types of information which are coupled. And that we know because people which were doing Euclidean geometry, they redid the diagrams. And we know that they redid them because we have variants. We have type of diagrams which are different. So it shows at the same time that the diagram itself is not essential to the proof in the sense that you can circulate all of the text and then reconstruct. But what you need is that you need to complement the text by some kind of other information. And usually the way that they did at the time was by diagrams. Then of course, if you're trained enough, if you are very good, you can code all of this information into language. So it's a complicated issue. It's not a question about do I need the figure or is it essential to the proof or so forth and so on. It's a question of the type of information that I'm using. What I claim is that in Descartes, there are information that you have to take from the diagram. Can you recover this information without the diagram? Absolutely. Absolutely. You can, if you give me Descartes' text, I can redo the diagram on the side and just do the same gesture and understand. But I have to understand what he's doing. And what he's doing is not giving me equation, is giving me a certain way to construct something, to construct some object. You see the point? So it's not as simple as using diagrams or this eternal question, or do I need the figure or not? It's way more complicated, according to me, but that I develop in my paper. I can send it to you at the end of my paper. It's a question of coupling information, having two types of information coupled. And what I claim is that Descartes is in this frame of mind. That is to say that when you do mathematics, you have various systems of information and you use them in a certain coupled way. And there are other ways to do mathematics in which you don't need to do it. There are other ways to do it. You can do it directly.
So just a very quick follow-up. So I'm not a Descartes scholar, so I work on Kant. But whenever I read out the chiliagon and the myriagon example in class, it does seem to me that there isn't a role for imagination in distinguishing the chiliagon and myriagon in a certain sense, because the imagination can't do it. How does your thesis fit with that particular example?
Okay, so I will send you another of my paper about Leibniz and this example. Okay, so that is true. That is true. That is to say, if the point is to recognize a picture, I cannot make a difference between a chiliagon and a myriagon, for sure. Okay, but this is not what we are doing in mathematics. What we are doing in mathematics is classifying objects, making proof about them, and so forth and so on. And so the big question is, how is it, and this is a question that was raised by Leibniz, how is it that if I give you, in fact, if I give you a chiliagon, it's a constructible object, but if I give you a chiliagon plus one side, it's not a constructible object in Euclidean geometry. This you have to explain. And this explanation relies on rules of construction. And you have to explain what is a rule of construction and what you're constructing. Okay. And all of this, Leibniz will call this the logic of imagination. This is his term. Okay. So imagination is not a problem of picturing. I mean, it's too simple to present it this way. It's not a problem of having a picture that I can recognize. It's a way of working with the object. And then we need to enter into the activity of the mathematician. The activity of mathematician is not to recognize the difference between a chiliagon and a myriagon. It's to recognize the difference between, as I said, a chiliagon and a chiliagon plus one side. And in fact, they are two completely different objects. Why? You see? And I have to explain why. But these are other issues that I mean, it's fascinating. I mean, it's really interesting and really fascinating. But I didn't give any clue about this in my talk. I have to say, it's normal that you ask this question. That was not the core of what I wanted to show.
Right. Maybe Dennis Sepper next.
Yes. Hi. Hi, David. Good
Hi.
to see you.
Good to see you.
As you know, I have great respect for your work. And this is not a preface, by the way, to now trying to devastate it. It's rather to go to that question of the relationship between intellect and imagination that might be illuminated by looking more carefully at Descartes' use of, well, let's say his use of symbols to mark certain things that present in images. I'm trying to be very careful in what I say here, but I guess I put it this way. if I take a line segment and I duplicate it and I join them end to end, I cannot see that the result, I cannot clearly and distinctly see that the result is twice as long as either of the line segments I started with, unless I track that. And if I track it by saying, I've drawn this one length A, this one length A, I now join them, what I have is 2A. So it means I can actually look, or I can close my eyes and not look and imagine in a more direct sense. And clearly and distinctly see that the resultant segment is twice as long as the original one. Okay, so there's no such thing. You always have to remember, imagination is not just about images, it's the way the mind takes the images.
I fully agree, but can I ask you, what about Euclid? So if I join AB and BC, what is the difference with your situation? According to me, it's the same situation. So it has nothing to do with algebra. It has
nothing to do with algebra until you say that the mind can track this better when it represents it. It represents it in a set of symbols that are coordinated with the original images. And this allows...
I agree, but when I do, for example, Euclid's algorithm in Euclid, I have to track the fact that I divide a number by a certain number of times, and either it finishes or not. Euclid does it by marking some segments with letters, so it's not algebra at all, and he marks the track of what is an algorithm. It's an algorithm according to us. It's a rule to divide and then divide the rest and so forth and so on. According to me, it's exactly what you're describing, and I agree with you. I agree fully. But my point is that
and the difference is that Descartes is saying that this use of the mind is thoroughgoingly an activity of proportionalization, which takes it beyond the immediate context of the way Euclid does geometry. But here I just want to criticize now the use. I get really irritated when people want to talk about pure intellect. You know, at best, I would allow something like pure intellection or pure intellecting. Similarly, there are no clear and distinct ideas. There is the clearly and distinctly perceiving of something. So there's always an action of the mind at work. So what we want to call pure intellect for Descartes is something that he has to resort to, and it's already in the rules. It's in the rules, to clearly and distinctly perceive a relationship that exceeds the ability of an image to directly express requires the mind. So he says you can use the same image, say of a triangle, for an extended figure and for extension. But it is inadequate as a representation of extension is not an extended thing. That is, you have to, as it were, step back and take the same image in two distinct ways. So what algebra does is track. You start with symbols that you put in proportional relationships to one another. This leads to equations, powers, and the like. But when you then universalize this and look to something like the Meditations, to recognize self, to recognize true infinity, to recognize God is a pure use of the intellect. And no particular image, not even a sequence of images, can represent the resultant. Though, as I always insist, Descartes has enough of the Aristotelian dictum, no thinking without images, in his work, that you need to try to go through a series of images to, for instance, approximate what you would conceive of as an infinite series. But the mind exceeds at that point. But if you try to eliminate images totally, there's no proper object of what you're doing, and therefore it can't be clearly seen, it cannot be distinctly seen. So, of course, I think this is all in his, initially he says he's not going to tell us exactly what the use of the vis cognoscens on its own is in rule 12. But then we find out, what is it, in 14, that you need that in order to recognize that an extended thing is not extension. My claim, of course, in my book in '96 was that this is a form of what the medievals called remotio. We could call it an indirect, a kind of indirect reasoning. But I just want to say, I think the use of mathematics is precisely where we, I think, begin to see emerge for Descartes a distinctive use of intellect, which we want to call pure intellect, and we want to attribute to algebra itself. And as you're rightly pointing out, that's not where it has its proper place, this kind of distinction.
Yeah, so I think that basically we agree. If
if
you agree with me that what Descartes is doing, so what you say about tracking is very interesting. So there is a French scholar, Jean-Louis Gardis, who wrote about the transformation of analysis through the ages, and he points to the fact that the rise of algebra, not only in Descartes, but before in Arabic authors, allow precisely this, precisely to track more and to track more efficiently. That doesn't mean that you could not track things in Euclidean geometry or in Apollonian geometry. You can track a lot with proportion, but you cannot track in the same way, and you need all the system of what the Euclids call the data. And so if you agree with me that this is an extension of this, so I think we basically agree. That is to say that algebra is just generalizing this work of proportionalization, and symbols are just a way to extend this, and what you could do with letters before also. And I think we agree. Yeah, I think we agree. We agree on that part. Yeah.
Right. I just one comment. One reason I think the Geometry did not need to circulate always with the diagrams is because Descartes insists that you do it for yourself. That is, you can produce a similar proof, if not an identical proof, but you've got to do it yourself. There are very few mathematicians who could just look at the algebraic formulas and say, ah, yes, I see. I won't deny that there might be some. I won't deny that there might be some, and we then unfortunately have to begin examining a properly empirical psychological question.
You're right, but my claim was about Euclid's geometry, to circulate with a diagram. And in fact, it's the same situation, because you need to redo the diagram anyway.
Right. Thank you.
Right. Let me introduce Ohad now. Ohad Naknami. Maybe the last question.
Hi, thanks, David. It was very interesting. I think my question is basically answered, but let me just put it forward anyway. So I think precisely in the meditations, it's very clear that there is, in the very definition of matter as extension and so on, Descartes wants to say that we don't need the imagination in some sense, and it can be understood and should be understood, just understood, right? I mean, I think that strand is difficult to deny. My question is whether this contradicts what you're saying. I gather that it's not, but I just want to clarify this.
No, it's not. No, it's not, because in fact, no, but it's not. It's not. But then you could ask another question, which is, does it contradict if I say that imagination is needed in mathematics? Which is maybe where you want to point. And I think it does not, precisely for the reason that I explained. And you have the same paradoxical statement in Proclus, that is to say that mathematics is purely intellectual. It derives its certainty for pure intellect and so forth and so on. But that simply doesn't prevent the fact that you need imagination to express distinctively this relation and this certainty. These are two separate issues. So de jure, all the certainty is contained in the pure intellect. It's the same in the Neoplatonism. It's exactly the same. But still, you need imagination to unfold the relation, as Proclus would say. And I think it's the same situation in Descartes. So there is no contradiction here. You can have both theses at once. But that's the difficult part. This is what I answered to Dan. That's the difficult part, because we need to understand precisely the relationship between imagination and pure intellect in conjunction with the fact that he will say that we need imagination in mathematics. That's the. But I think we can. I think we can.
Thank you.
Okay, Hanok, last question then.
If we have time, I deliberately waited. Do we have time, Dana? So
Well, that depends on how much do we want to extend one talk into two in the place of two talks. But if you keep it short, I think we can take another question.
But,
and if David agrees to.
Oh yeah, I fully agree.
So two small comments, remarks. One on the related ones. One on the discussion you had with Des, which I found really interesting, and these questions really interest me, but it was more like, can Descartes justify his, epistemologically, can he justify his method? Perhaps he can, perhaps he cannot, perhaps he thought about it, perhaps he didn't, but David addressed in his talk what he actually does, which is unlike what we find described, stated by many commentators. So these are two separate things. And another thing, David mentioned several times the continuation with the Neoplatonism. And I don't know enough about Proclus and so on, but the little I know agrees with that. But they had, related to this discussion we had between you, a different answer. We see the ideas, the forms in the particular, and that's why we can generalize from the particular to the universal, and we find this already in Plato and so on. This is not available to Descartes. Whether he had something different or not, I don't know.
So this relates to a question that was raised by Marco, because he asked me, will you go as far as saying that Descartes take again this idea of pluralization, the role of imagination to make several exemplars of one unique idea? And just to, so apparently, no. I mean, it's a different issue, and Descartes is not using this, but it's a subtle issue. I just want to point to something that was analyzed by our friend and colleague Sébastien Marron in his PhD. When Descartes solved Pappus' problem, he's forced to choose a particular situation of the line. Because he chose this particular situation of the line for 4 lines, he has particular position of the points. And because of that, he will have signs appearing whether or not some entities are on one side or the other side of this point. But since this point was arbitrary, he has to envisage all the cases. If you do pure algebra, you don't need to do that. And Sébastien showed very well that, in fact, Descartes will have very strange situation in which he has local equation for one and the same curve, and it does not say it that it's the same curve, because it appears in specific cases in his combinatorics of sine and of algebra. And so it's a complex issue, because in Descartes, the diagrams are not generic. They are not generic. So we are back to the problem that was raised by the Neoplatonician. In a way, you need to see the universal in the particular. And this is not trivial. This is something that you have to construct in a certain specific reasoning. And this is what Descartes does. And this contradicts completely a certain reading of Descartes' practice that you find in, for example, in Kahneman's, in which he will claim that because I have the equation, I have all the cases. And when you look at the way in which he solves Pappus' problem, this is simply not true. So it's a complex question. And then, of course, you're right. The fact that it does that, it's one thing. Whether or not it matches with what he says, it's another issue. And the question of pluralization is not a question that he raised at all. But in his practice, it's a complicated matter. It's not a straightforward answer to this question.
Well, on this note, I think we all want the second paper by David sometimes next year in our Princeton-Bucharest seminar, because I really want to read it or listen to it. Meanwhile, let's thank him for this wonderful evening. And it's the end of the 49th edition or whatever meeting of the Princeton-Bucharest seminar, and I'm passing the floor to Dan now.
Thank you very much, Donna. My temptation is actually to continue the discussion, but I won't. There's so much more to talk about in these issues. But I do want to announce that to close off this season, we can't end at 49. We need a 50th session. So we are proposing next week to have a short holiday party. Tuesday, December 14th, 1 p.m. Princeton time, 8 p.m. Bucharest time, 7 p.m. Paris time. And come, meet, chat, and share your answer to the following question. What was the most interesting, unusual, rewarding, or amusing thing you've learned with respect to early modern philosophy in 2021? And we hope to see you here. Bring your own wine, cocktail, or whatever. And we are going to meet a week from today. Thank you very, very much.
Thank you. See you next week.
Thank you. Bye-bye.